Okay, good evening everyone. No more delay, I will start the session for the week 2. Hope I am audible and my screens are visible. Can anyone respond please? Am I audible and my screens are visible? I can also put it in the chat box please. Yeah, okay, fine. You can hear me. Fine. I'll start the session. Okay, so we are in the second week of this NPTEL problem solving session for the course air pollution and control. So yesterday we have seen the week 1 session. So I formally just introduce about me. Some more new participant may be there today. So I'll just give a small introduction. I am Saravanan, Prime Minister Research Fellow and PhD scholar in Department of Civil Engineering in NIT Tiruchirappalli. So as a part of PMR of deliverable, I have to take at least 4 hours of a TA shift class in outside colleges other than my hosting institute. So as a part of PMRF deliverable, I am taking this course in NPTEL in air pollution and control. Yeah. So this is the second week for the 12-week course. In the first week, we have discussed about what is air pollution, what are the different air pollutants, and its history, history of air pollutants, and how it affects the human health, plants, and animals. So these are all we had seen in the first week. So this week we are going to discuss about the air pollution and its impact on the soil, water body, and different meteorological condition that affects the dispersion of air pollutants, because all the air pollutants that are released from the source should be transported somewhere and it will be transformed into some other pollutants, right? That's what we have discussed yesterday. So after transformation, for this transformation to occur, different meteorological conditions in the atmosphere may help or may retard the transformation process. So that's what we are going to see today. Different meteorological conditions like wind, temperature, wind speed, wind direction, humidity. As we mentioned, water may affect the formation of acid rain. So this type of meteorological parameters that may affect the transformation of air pollutant. That and all we are going to see in this week. Okay. So firstly, we will move through the lecture material. Yeah. And then first 1 hour we are going to discuss about the same lecture that professor has taught, Professor Bolaguram Gurje from IIT Roorkee. I am using his same material for first 1 hour, and then second 1 hour I am going to discuss about the old assignment problems. So I got the access for the Excel sheet. So you can see now I have uploaded all the videos that I have recorded and all the lecture materials and the problem solving materials. You can view the Excel sheet now from the Swayam portal. I will also show at the end of the session. Yeah. So today we are going to discuss about, yeah, one second. Yeah. So today we are going to discuss about the impact of air pollutant on the atmosphere. So how it will affect the atmosphere. Yesterday we had seen about the human health, animals and the plant health. Now we are going to see how it's affecting the atmosphere. You know what is atmosphere? In biosphere we have three components. One is atmosphere, lithosphere and hydrosphere. Atmosphere is the one which contains the whole air. So whenever the greenhouse gas rises in the air, that is a air pollutant again, carbon dioxide and methane, that raises the temperature of the earth. So it is again a problem to the atmosphere. How it will rise the temperature? By trapping the longer wavelength radiation. So the sun may emit different radiation. Some are longer wavelength radiations, so that will reflect from the earth surface and back to the space. But if this type of greenhouse gas pollutants are present in the air like carbon dioxide and methane, that will reflect back the radiated reflected radiation back to the earth again. So it will trap the heat inside the earth itself. So that is a problem here. So the air pollutant affect the albedo of the earth surface. What is called the albedo? Albedo is the reflecting property. So earth will act like a mirror. So whenever the light falls on a mirror, it will reflect, right? So like that the same, whenever a radiation falls on the earth's surface, it will reflect. Earth have the natural property of reflecting the sun's radiation. But whenever this type of pollutants are present, this affects the albedo. Albedo is the reflecting property of the earth's surface. So like carbon dioxide, sulfur dioxide, nitrous oxide, that may create acid rain. These are all some of the other impact on the atmosphere. Visibility will also get reduced. So you can see the example like in Delhi, you can see how the visibility got affected in November 2008 and 2020. So this will be based on weather condition also, as well as the regional air pollution. And see the year 2018 it got polluted, and lockdown during 2020 the visibility got improved. So there is no vehicle, less movement of vehicle, less emission. So less emission, less smoke formation. So that's the direct relation you can see. Okay, then the air pollution and the visibility got affected by visibility. You know how the observer can see the scene. So so that is affecting the aesthetic condition of any tourism place and all. So whenever a light is reflected from a surface, that will directly seen by our eyes. But whenever there is a particle present in between the observer and the thing that is reflecting the light, then the light will be again reflected back some other place. So that will affect the visibility of that thing what is reflecting the light. So that will reduce the contrast and reduce our ability to see the object. So that's why there should not be any particle on the atmosphere to reflect the light radiation, so that we could not able to see that object clearly. So how haze affects the visibility? Haze is caused when sunlight encounters tiny pollution particles. So anywhere sunlight will be reflected by this type of smaller particles in the atmosphere. So that scattering of light reduces the visibility. Got it? So we have three types of haze. One is plume haze. Second one is layered haze. Third one is uniform haze. So the plume haze is the one which will be directly vertically emitted by a single point source. You can see this dark particles or any smaller size or smoke particles are emitted from the single point source. But if it is a layered haze, that will be that we can see only this point source is having less visibility. But in this layered haze, you can see different layers are between a contrast layer. We could see a less visibility. If it is a uniform or unstable haze, if you see everywhere it will be a haze, not only a point or not only a layer, everywhere you could see less visibility. That's a uniform haze. So what is the effect if there is a less visibility? Then as I mentioned yesterday itself, that lots of car accident or automobile accident may happen, and low visibility can lead to accident. That's what we have mentioned, and affects the transportation and tourism. So you could not able to see the tourism place clearly. That's a good visibility will get affected. Okay. So, a sharp decrease in the visibility due to increased particulate matter. Again, in the Delhi example, in November 2012, smog effect they are quoting. And albedo. Albedo, as I mentioned, it's a principle or a process of scattering of light, the fraction of light that is reflected by the body or the surface. So, if it is more light deflected, then it is more albedo. 100% of light is coming, 80% got reflected. Only 20% is observed by the object. That it is called high reflection, high albedo. In 100% radiation, only 10% got reflected, other 90% got absorbed. That it is low albedo. So how much fraction of light that is reflected is directly proportional to the albedo. Okay. What will happen if more light is absorbed? It will increase the production of heat, or it will generate lots of heat in the object. That is the other problem. If the ice have the property that the ice will melt if it absorbs the lots of the radiation. The normal ice will have a good high albedo. It will reflect the light. But whenever there is a particle that sticks to the air pollutant, that is sticks to the ice or the snow present in the hilly regions, it will reduce its albedo, and it will reflect only smaller radiation, and all the radiation will get absorbed and it will melt the ice. That's the other problem related to albedo. So that's a soot or the particle that enters the atmosphere, it absorbs sunlight and generate heat and warm the air. So again, global warming is happening. That's what the soot is deposited on the snow or the ice that changes the albedo of the surface, and it reduces the albedo and the ice got melted. Okay, that will again a problem of global warming. If the ice melt, sea level will rise. If the sea level rise, land area will get reduced. So it's a again and again it's a simultaneous effects. So again, the soot particles are the dust particle. If it is covering the Earth's surface, then what will happen? This is a good effect. Here you can see instead of ozone, this particles will also scatter the light particle that in the stratosphere itself. So that will again helps the planet to cool down. So there are good and bad things also. So ozone is trapping the heat by reflecting the radiation. In the same way, this type of stratospheric aerosol particle will reflect the radiation and cools the planet. That is one positive thing about the aerosols or albedo. The same albedo, if the sea particles are present, sea particles reflect sunlight back to the space and cools the atmosphere. That is one good thing. If it is a black carbon particle, then it will absorb the radiation and it will warm the. That's what we will say. Like some people will say, we should not wear black clothes. It will absorb more heat energy. That's the reason behind this color and the light radiation absorption. So if it is a white particle or a sea salt particle, it will reflect larger light and it will cooling effect will happen to the atmosphere. If it is a darker particle, it will absorb more light and it will be a warming effect to the atmosphere. So that's the problem with the air pollutant also. If it is a sea salt particle, that is a good effect. If it is a black carbon particle, that is having a bad effect, impact on the atmosphere I'm talking about. Okay, so what is the impact on the climate? Again, pollutant releases into the air via car exhaust or this type of smoke that may be a greenhouse gas, and it will induce the global warming. That is the impact on the climate, and aerosol can induce either warming or cooling effect in the atmosphere. So here you can see the cloud. If it is formed, then cloud may reflect the sun radiation. So some will trap the heat. So one is having a cooling effect, one is having a warming effect. So here you can see the greenhouse gas remains in the atmosphere. One second, I will move this down. Yeah. So greenhouse gas remains in the atmosphere for years, that much longer than the aerosol particle can stay in the atmosphere. So you can see how much impact of greenhouse gas than the aerosol particles. So they will stay in the atmosphere for longer years and they will reflect the radiation within the Earth surface itself. So it will warm the Earth atmosphere. That's the warming effect. Warming effect of global greenhouse gas is larger than the cooling effect of the aerosol. So one side it is positive, one side it is negative. But if you see the net effect, it is a negative effect only. So here you can see long-lived greenhouse gases are generating lots of heat. But what we say like short-living aerosol particles are having smaller cooling effect. As a net, you could see the larger heating effect only. So it's a negative effect. So the change in the temperature pattern is happening. You could see like last 200 years, you could see the temperature increase of around 1.5 degrees Celsius. That's what we have discussed yesterday. So we could see an average of 1.8 degrees Fahrenheit or 1 degree rise from 1900 to 2020, 120 years itself. So if the temperature pattern changes, it will change the precipitation rainfall pattern also. So there is a lot of rainfall you could see. There is a cloud burst and this type of critical events are happening nowadays. In a smaller, shorter duration, we could expect a lots of rainfall happening. The rainfall which is expected in the whole year is happening in a single day or a single week. In Chennai also, you could see lots of flood happening. So this type of things are due to climate change effects. So which are all directly proportional, directly linked with the air pollutants. So that's the impact on the climate, like glaciers are shrinking, so all the ice are getting melting, and the sea level is rising to around 1.7 mm per year. So you could see how much 1.7 mm is minimum, but as a whole global area, if you see 1.7 mm, then it is a bigger value. Then the CO2 level got increased. What will happen if the CO2 level got increased? It will trap lots of heat energy. Again, this heat energy, global warming, will melt the ice. That's the thing. That's why it shrinks about 40% of Arctic ice cover. So earlier it was this much ice cover. Now it is only 60% is pending. So now we have seen about the air pollutant and its impact on the atmosphere. Now we are going to see about its impact on the soil. Soil also it's having an impact, like as we mentioned, acid rain due to sulfates and nitrates that will react with the moisture in the atmosphere, and it will produce the H2SO4 and HNO3 that will affect the plant growth. When it falls on the soil, it has a negative impact, like acid deposits reduces the productivity of the plant. So what are the soil characteristics that will get affected, like pH, water holding capacity, that is WHC, nutrient like NPK. These are all main nutrient required for the plant growth in the agriculture. And the salinity should be low. If any sea salt are transported and deposited on the agricultural land, then it will reduce the productivity of the plant or productivity of the soil. So pH, if you see, the optimal pH required for the plant growth is 6.5 to 6.2 to 6.8. That is in the neutral range. 6 to 8 is the neutral range. So 8 to 9 is the alkaline range, and less than 6 is the acidic range. Above 9, this is highly alkaline soil. So if it is too alkaline and too acidic, it will not retain the required macronutrients or micronutrients. That's the problem. So again, the sulfuric and nitric attack, and water holding capacity will get affected. Required amount is 40 to 50%. That is the minimum water holding capacity. What is called water holding capacity? The soil can hold as much of water it can after drained with the gravity. So if you take some soil in a plate or a cylindrical pipe, and pour some water, after draining all the water due to gravity, some water will be held by the soil particle. That is called the water holding capacity of the soil. So that's why the plant can absorb the water that is sticking to the surface of the soil. It will absorbing, and it will taking it for its growth. So the water that is held by the soil is important for the plant growth. So water holding capacity get affected because of this type of air pollutant that is coming to the soil. Again, nutrient and macro and micronutrient absorption got reduced, and the amount of salt that is deposited on the soil affects the plant growth. Yeah. So the particulate matter like dust, smoke, and dirt having a very specific chemical parameters, and the nutrient content of the soil were severely affected due to air pollution. You can see like the emissions from different automobiles are deposited on the soil, and it will be absorbed by the plant. Then the plant will be consumed by the human being. It's entering into the food chain. So oxides of sulfur again leads to acid rain, and lead reduces the productivity of the soil. So lead from the leaded petrols or emission from the automobiles. So what is the calcium carbonate and its role in the soil? If the calcium carbonate is high in soil, it will neutralize the acid effect. Whenever there is a sulfuric acid and nitric acid that is falling on the soil containing calcium carbonate, then the calcium carbonate will neutralize the acidic effect by absorbing the sulfate produced, and it will give you calcium sulfate. So it will not have any effect. So more resistance to acid rain. When the carbonate calcium free soil or calcium carbonate free soil, then it is more vulnerable to acid rain. You got it? So that's the problem here. So when the soil is having good CaCO3, it will resist the acid rain. If the soil having less calcium carbonate, then it is vulnerable to acid rain. When the soil is contaminated with heavy metal from the air pollutants, then it will be absorbed by the plant and accumulated to the plant body. This is one of our research area. I could also try to explain my research area when time permits. I will show. I'm working on actually landfill mining, solid waste management. I will explain my research also. Yeah, one day. And the acidic impact on the water bodies, like as I mentioned, whenever there is a slight reduction or increase in the pH of the water bodies, from 6 to 5.5 or 6 to 6.5. So this type of zero point 0.5 variation in the pH level could have a huge impact on the aquatic life. So you could see different lethal effects on the fish and aquatic organisms, and then acid shocks you can see. And then you can see the same effect in the Iraq. Larger sulfur mine is happening. Then from the emission of sulfur dioxide creates the acid rain, and the pH was lower than 5. Most fish were not hatched. So there could be a reproduction issue, and lower pH also killed adult fishes. That's the problem. The whole aquatic organism got lethal effect. So then the thermal impact, as I mentioned, global temperature will get increased. Ozone absorb most of the excess heat from the greenhouse emission, leading to rising the ozone temperature. So if the ozone temperature got rises, this type of coral reef bleaching may happen. So it will bleach all the coral reef, because this is again a calcium carbonate only. So that is getting affected. Then eutrophication. Many of you are from environmental engineering. You may know when there is excess nutrient content in the water, then it will produce more algae in the water. That we say this green algae that may surround the surface of the water. Then it will affect the circulation of oxygen in the water. If there is no oxygen in the water, the fish cannot respirate the oxygen, so it will die. That's the indirect effect. So whenever there is a rapid and significant increase in the plant and the algal growth due to the more availability of nutrients and nitrogen, then the excessive growth within the body is called water body is called eutrophication. That will reduce the level of dissolved oxygen. So this algae will take all the oxygen. So and then there won't be any oxygen left for the fishes. So that will, and there won't be any circulation of oxygen from the atmosphere to the water body. So the fishes may die. So these are all the effect of air pollutant on the atmosphere and to the soil. Here you can see the different air pollutants and its classification. That's what we are moving into the theme area. So whenever different types of emissions are there. As we mentioned, there may be a natural emission, there may be a area emission. If there is a whole community is creating the pollutant, then it is called area emission. If it is a SIPCOT area or any industrial area, that whole area will create the pollution. That's called area pollutant. Stationary pollutant is only one industrial stack is creating a pollutant or emitting the pollutant, then it is a stationary pollutant. Mobile is like it's moving, or a line pollutant. When a vehicle is emitting from this end to that end, then it is called a line or mobile pollutant. So based on this, we have based on the source of air pollution, we can have two different types. One is natural and anthropogenic. Natural in the sense sea salt, dust storms, smoke from the wildfires, volcanic activities, pollen grains, these are all. Anthropogenic, the stationary sources like power plant and all, that will be there, industries and all. Mobile source like transports, what we say, automobiles. And then area sources like agricultural field, landfills is one of the area source for emission of methane. Then cooking, waste burning, wood burning, these are all you could see the area sources. Okay, then in the natural sources you could see like volcanic eruption will release all this type of sulfates and carbon compounds, and that may create acid rain. You could see like in Mount St. Helen in 1980 to 2005 has released a huge amount of SO2, around 3,750 tons per day. So you could see how much impact it happened to the pH of the water bodies that got deposited. So now still we have active volcanoes around the world. In August 2021 data, we could see 50 volcanoes were in continuing eruption status. So still we are getting emissions from the volcanoes and having sulfur emission into the atmosphere. Then forest fire, that may be natural or a man-made forest fire. So that will also release, because most are carbon compounds, right? What are the trees and all. So it will emit carbon monoxide and carbon dioxide. If it is a huge oxygen, carbon dioxide will form. If it is incomplete combustion, then carbon monoxide will be formed, hydrocarbon, ash, oxides of nitrogen, everything will be formed. So you could see in a year itself, 37,000 fires are happening in forests. So that's the data. So 54% of the forest area exposed to occasional fires, and 7% of the forest there are having a moderate frequent fires, and 35% are exposed to not exposed to fire. So we could still have a option to survive. Then Australian bushfire, this was recent in 2020. You could see like how much happened, 715 million tons of carbon dioxide is emitted into the air. That's the Australian bushfire in Sydney. And the natural source of air pollution, you can see like dust storms. These are all the natural activity in deserts and nearby areas. You could see the what we say like a tornado of dust storms. So that will affect the visibility. Then in New South Wales in Australia, there also you could see that visibility dropped due to dust storms and sand. Then natural sources again there is a ocean that may emit the sea salt what we have discussed. And that's having a corrosive property to the material and also to the buildings. So what are the marine aerosols? Sea salt, sulfate aerosols, nitrate aerosols, and the mineral dust. These are all the marine aerosols, coastal aerosols we will say. So that will be coming out of the marine regions. So how it's coming out? Whenever the bubble that is coming to the top surface of the sea, that will burst and form a film droplets, or that may form a jet droplets. So that will be emitted into the atmosphere. Film drop is the one that may shatter at the thin upper surface of the bubble, and it will ejected and wide angular distribution. Like this angular, it will distribute everywhere. If it is a jet drop, then you could see here here this is a jet drop. So there is a larger aerosol particle because these are all smaller particle after bursting. These are all larger particles around 10% of that of the precursor by bubble diameter. So what are the effects? This marine aerosols may attack different metallic compounds and have corrosion effects. You could see lots of marine structures are getting affected due to the aerosols, marine aerosols. Metals only, everything ferrous or zinc metals without galvanizing layers. Then pollen grains, that is again a natural air pollutant that may cause a respiratory distress and allergic reaction in the human beings. Pollen allergy in Europe is studied in 2016. There are around 150 million European citizens are getting affected. In 2025, you could see more than 50% of the Europeans are will suffer allergy with no age and social and geographical distinction. That is a study report. In Bangalore also you can see the pollen allergy of around patient with the allergic rhinitis, and 400 patients are included in the study. 21 yarrow allergen extracted from their body. You could see like 9 specimens of pollen, 7 species of fungi, 3 species of house dust mites. These are all called the indoor air pollutant and the outdoor air pollutant also. Both are involved in. So that will have a particle size less than the nasal cavity, so that may easily enter into the human body. So you could see like persons having allergy sensitivity to mostly 57% of the people are having allergic to the dust mites, and 25% are having allergy to the pollens, and 8% to the fungus. So you could see lots of things are related with the fungus, pollens, and the house mites. Then the anthropogenic activity. As of now, we have discussed about the natural sources like volcanic eruption, forest fire, coastal aerosols, and then this type of pollens. Now we are going to think about the man-made emissions. First is the industrial stack emission. Like combustion, all industry need heat, so that is burning lots of fuels like diesel, LPG, kerosene, wood, coal, natural gases. Everything whenever you combust, there will be emission of pollutants. So that will be released from the stack and chimneys like sulfur dioxide, carbon monoxide, and nitrogen oxide will be emitted. Okay. So first is the power plant chimney, that in India itself 70% of the power generation is via coal only. So there could be a lot of emission of SOx, NOx, carbon dioxide, CFCs, and suspended particulate matters. Then from the automobile, that is a line source or a line source emission. So there could be a exhaust emission of CO2, COHC, and non-exhaust emission of particulate matter, heavy metal, and the evaporating emission of whatever the diesel that may evaporate as hydrocarbon directly, because that is a hydrocarbon, diesel or petrol that will directly evaporate as hydrocarbons and volatile organic carbons. Then worst burning, if you are burning something in your backyard, that may emit a lot of particulate matter, carbon monoxide, because there will be an incomplete combustion, and PAH, SOx, NOx, and VOC. So everything will happen. Indoor air pollutant is again man-made only. That is not rapidly disposed by the wind, but it will be inside the wall of your house, and it will create a residential problem. Yeah. So again, based on the source, we have two classification: natural and anthropogenic. Now we are going to think about the based on the formation, we can split into primary air pollutant and secondary air pollutant. What are primary air pollutant? These are the one which was directly emitted from the source. What are the secondary air pollutant that are formed from the primary air pollutant? Okay, so sulfur dioxide that is emitted from the vehicle, carbon monoxide from incomplete combustion. These are all direct emission. That are all primary pollutant. But the acid H2SO4 or HNO3 or the ozone that is formed from sunlight and the VOC. So these are all secondary pollutant formed from the primary pollutant and with some catalyst. You got it? So these are all primary air pollutant and secondary air pollutant. The third classification is the criteria air pollutant. So in NAAQS standards, National Air Ambient Air Quality Standards, NAAQS, that's the National Ambient Air Quality Standards. So they have a guideline for to monitor six major criteria air pollutant. Be remember with this six that are major, very important: ground level ozone, particulate matter, particulate matter includes both 10 and 2.5, and carbon monoxide, lead, SOx and NOx, SOx sulfur dioxide and NOx nitrogen dioxide. Okay, so this six are the criteria air pollutant need to be monitored periodically. And then there is other 187 different hazardous air pollutant given in the standards. Okay. So first we are going to see about the carbon monoxide, that is a byproduct of incomplete combustion. As we know that there is no much oxygen is there, then carbon monoxide will be formed. So you could see that carbon dioxide is not in the criteria pollutant. So carbon monoxide is having a major effect than carbon dioxide. Then sulfur dioxide, that will be a colorless gas, and it will have a smell of burnt matchsticks that will be formed from burning of fuels, coals in the oil, and it may also produce it from the natural sources like volcanic eruptions. And nitrogen dioxide, that is a reddish brown color emission from the fossil fuels when they are burned. So they may also produce it from the exhaust emissions. And this SO2 and NO2 are responsible for acid rain, as we have discussed for the last 2 weeks. And then ammonia. Ammonia is a very soluble, colorless gas, having a strong pungent smell. You could see that pungent egg smell, that is due to ammonia only. In lab also, you could see ammonia buffer have that smell. Okay, that is released from the animal waste. Whenever there is a organic matter getting degraded, the nitrogen will be first converted to ammoniacal nitrogen, then it will be to nitrate and then nitrite. Like that, it will go. Okay, so nitrite, then nitrate. Then particulate matter is the mixture of solids, liquid, or both the particles. So based on the size, we could see it split into coarse, fine, and ultra fine particulate matters. Then the aerodynamic property. Why we have to discuss about the aerodynamic property? Because whatever the particle that are emitted in its own size, because of its density, it could accumulate in the body. So that's called aerodynamic particle diameter. That's what we are going to discuss. That governs the transport and removal of particle, influences their deposition within the respiratory system. That's what the major human health effect. Then it is associated with the chemical composition and sources of the particles. So that's the diameter, aerodynamic diameter. That's the diameter of the spherical particle with a unit density of 1 gram per centimeter cube with the same settling velocity as the particle that is to be characterized. But the normal stroke diameter is the one, that is the diameter of the particle. If you take a single piece of soil, it may settle at a velocity, it has its own settling velocity on its same density. But if it is having a density of 1 gram per centimeter cube, then how it will settle? That's called the aerodynamic diameter. You got it? So the diameter of its own particle, which will settle on its own density, then it's a stroke diameter, that is the normal diameter. When the density was 1 gram per centimeter cube, then how much diameter it requires when the settling up for its same settling velocity, then it is called the aerodynamic diameter. So that could be given by this formula. If you want the aerodynamic diameter, then the normal diameter, that's the stroke diameter, into root of particular density. So just a formula, derived formula you could see here. You can see here, see, all the particle have the same aerodynamic diameter of 2 micrometer, but its own diameter varies like 1.4, 2.8, 2.3. But still its density is different. You got it? Based on the density, the diameter, aerodynamic diameter varies. Yeah. So here you can see different air pollutant like dust, smoke, fumes, mist, fog, and aerosols having diameters. Bigger particle is the dust, then smoke, 0.1 to 1 micrometer. Then finally smaller particles are the aerosol having less than 1 micrometer diameter, having different sources and different health issues. You can see the images of dust, smoke, industrial fumes, chemical fumes, mist, fog. If it both smoke and fog combines, that is called smog. and aerosols are the particle less than. Aerosol will come from perfumes also. Whatever the perfume you are using in the home, that is an indoor air pollutant. That is having volatile organic carbon, having particle size less than 1 micrometer when you spray. So that's again a air pollutant. Got it? Yeah. So you could see the comparison of particle size with the human hair. So human hair is having a diameter of 180 micrometer, but the grain of pollen grains are 15 micrometer only. Dust are 10 micrometer only. That is a PM10, and PM 2.5 you could see here, and the coronavirus you can see here. That much small. That easily it could enter into the nostril and enter into the respiratory system. That's the problem we have faced during COVID. And ozone is other criteria air pollutant that have a three atoms of oxygen. If it is two oxygen, if it is three, that is ozone, formed from the photochemical reaction. That is very important. Photochemical reaction, whenever sunlight reacts with the nitrous oxide that is released from the trans automobiles, along with the VOC, it will create the ozone. You got it? So that's the ground level ozone. If it is formed in the stratosphere, that is good. That will protect us from the ultraviolet radiation. When it is formed in the ground level, then it is hazardous to the human health. Okay. Whenever there is a NOx and volatile organic carbon, when it is reacting with the sunlight, so most of the ozone is formed during daytime. Whenever 6 to 8 p.m. because there is lots of automobile during that time. So you could see that graph also. So good ozone is the one in the stratospheric ozone, bad ozone is the one in the ground level ozone having health effect. How the photochemical smog is forming? Photochemical smog, once the water is reacted with the nitrous oxide, that is the NO2 formed from the emitted from the automobiles, it creates NO, and one ozone will be released, one oxygen will be released. Then oxygen will be reacted with the O2 and forms the ozone. And this NO will also create PAN, peroxyacetyl nitrite, and then aldehydes. These are all different secondary pollutant produced from the one primary pollutant, that is NO2. You got it? Along with the solar radiation as a catalyst. So these are all the problems with the secondary pollutant and smog, photochemical smog. Why it is called photochemical smog? Photo is the sunlight, chemical is the reaction between NO2 and the sunlight, the formation of a smog. It's a smoke plus fog, that is called smog. It will create eye irritation. It's a brown haze pollutant. Okay, that's the criteria air pollutant. We have discussed about the six criteria air pollutant: ozone, particulate matter, lead, PM, SO2, and NO2. So that is given by the National Ambient Air Quality Standards, NOx standards. So they have a defined levels for the air quality. If it exceeds, you have to reduce it. That's a criteria air pollutant. And in the new amendment, they have 12 parameters instead of 6. So that also you can see, but these 6 are very, very important. So they have divided the PM into 10 and 2.5, and they have added ammonia, nickel, arsenic, and benzopyrene, benzene, and all they have added as a new codes, revised the NAAQS code. But AQI is still following the old 6 air pollutant criteria for. So everyday newspaper you can see the air quality index AQI. So based on the AQI, we can say good, moderate, bad, or worst air quality. So that is calculated based on this 6 only. Instead of lead, they have divided PM into two things. You got it? So these are the important thing. Then hazardous air pollutants are benzene. These are all some of the example that is toxic to the human health. Benzene, perchloronitride, methylene chloride, dioxins. These are all hazardous air pollutants. So that is having a separate CAS number, that is Chemical Abstract Service Number, CAS number. So you can see the different chemical name with its catalog number. That is a catalog number we will say. So 189 pollutants are listed by the EPA, Environmental Protection Agency of US, United States, that listed the hazardous air pollutant 189. And greenhouse gases, as you know, carbon dioxide, methane, nitrous oxide, and fluorinated gases, that HFs. This type of hydrocarbons are also having global warming effect. So nowadays, lots of refrigerants are emitting this fluorinated gases are all banned. So we are moving to different green refrigerants. So you can see like where and all the greenhouse gases getting emitted. Yeah. So emitting trends in India, you could see still we are in rising phase with the greenhouse gas emission. We are trying to avoid the CO2 emission still. Yeah. Now we are going to see the atmospheric formation and fate of the pollutant. Now we have a clear idea about what are the different types of pollutant, what are the pollutant. Now how it is going to be transformed and what is the fate, where it is going to be deposited. So that we are going to see by the transformation reactions. So you can see emission, after that it will form and then it will disperse, it will concentrate on some part. So that's the man-made sources are transformed into secondary pollutant through reactions in the atmosphere. So that's the emission, dispersion, transformation, and then deposition by dry and wet transfer. So different transformation or formation processes are listed here: volatilization, absorption, adsorption, oxidation reduction, ionization, hydrolysis, photolysis, and metal catalysis. This is simple chemical terms. You can see from the name itself. What is volatilization? Volatilization is the conversion into vapor directly from soil. So from the soil, if it is converted to vapor, then it is called volatilization. That is a physical property. Adsorption and absorption. So ab in the sense it's absorbing the water. Whenever you are placing a sponge in the water, the sponge will absorb all the water. But whenever you are putting activated carbon in the water, the pollutant in the water is getting adsorbed on the surface of the activated carbon. That is called adsorption. Okay, so the transfer of gaseous pollutant from the air into the contact liquid, then it is called absorption. Contaminant retained on the surface of the solid particle, then it is called adsorption. You got it. Both are chemical and physical property. Then oxidation and reduction. Once the electron is lost, then it is called oxidation. Once the electron is gained, then it is reduction. Both are physical and chemical properties. Ionization is the one which will split into different ions. You can see NaCl we can split into Na plus and Cl minus. So this type of separation of compound into cations and anions are called ionization process. This is a proper chemical reaction. And hydrolysis. Hydrolysis is simple addition of moisture or reaction with the moisture. The same is happening with the acid rain. SO2 and NO2 are reacting with the H2O. That is called hydrolysis or hydration. And then it is giving acids. That's a chemical reaction again. Photolysis is reaction with the sunlight or UV radiations. So reaction does light catalyzes the process. So ozone is formed from this type of NO plus O in the presence of sunlight. That's again chemical and physical property. Then metal catalysis. Catalysis is the process of boosting the rate of the process. So by using metals, then it is called metal catalysis. So what are the metal they are using? Like platinum and rhodium catalyst that may helps uh, to boost up the reaction. That is again a chemical reaction. Then complete combustion. Complete combustion will give you only CO2 and H2O. This is very important. So whenever you are fully combusting a organic matter with oxygen, like octane is organic matter for example, and you are giving full supply of oxygen, then complete combustion is happening, is produced CO2 and H2O alone. If it is a partial or incomplete combustion, then you could expect carbon monoxide, that is CO. Okay, that is called incomplete combustion. Other than CO, lot other pollutions and organic pollutants may emit, like PAH, dioxins, and furans may also emit. Then heterogeneous reaction, like gas, liquid, gas, solid phases reactions. So you could see like SO2 is absorbed in the liquid droplets. Then it is a gas with liquid. That is a heterogeneous reaction. You can see like gas to gas is again a phase transformation. Gas to liquid, gas to solid, everything is a phase transformation. One phase to another phase, it's transforming. So ozone is the example. You can see like it's formed with one metal or one catalyst. When it is reacting with one molecule of oxygen in the presence of oxygen, then it will give you ozone plus that same metal. So that will catalyze the reaction. Yeah, here nitrous dioxide is acting as a catalyzing element. NO2 will be reacting with the sunlight and it will give you O and NO. One O will be separated from the NO2. That O is reacting with the O2 in the presence of volatile organic matter and it will give you O3. That's the ozone. But the ground level ozone is not always having a higher lifetime. So it will simply split again into O2 and O. Within the short lifespan, it has a major health impacts. Yeah. So you can see the same ozone formation with the volatile organic carbons. That's the tropospheric ozone having a problem with the smog formation again. Then diurnal cycle of ozone. See, you can see like from 6 to 8, you could see lot of emission of nitrous oxide. then nitrous oxide will convert it to NO2, then NO2 will be giving one oxygen to the atmosphere that will react with the atmospheric oxygen and it will form the ozone during the midday time. So that's the diurnal cycle of ozone formation. This gas to liquid formation. So as we know, like SO2 is reacting with the water, transforming into a liquid phase, producing sulfuric acid. That's the reaction. Same with the nitrous oxide that's creating acid rain with the HNO3. Then gas to solid. How the gas is forming into solid? The same HNO3 formed from the NO2 will react with ammonia and it may form nitrate particles. That's a solid particle. That may also settle in the soil. It will affect the plant growth. The leftover ammonia or the excess ammonia can be used to react with the HNO3 and forms the ammonia nitrate particles. So this is a gas to gas, gas with liquid, gas with volatile organic compound may form PAN, and there's some photochemical smog reactions like NO, VOC, and O2 plus sunlight may give you O3, PAN, and other oxidants. So these oxidants are major pollutants in the air and have a huge effect on the human health. Yeah, this is what we have discussed. Then three-phase system also there, gas to liquid, then liquid to gas. That is the same acid rain formation only. When it is reacting with the cloud water, that will give you HNO3. Then again it will split into NO3 solid. First it was gas, then it was acid, then it will become a solid again. That's the NO3 solid. So that solid is deposited directly as a wet deposit, or it may be directly as a dry deposit, or it may form an acid and it may deposit as a wet deposit. So there are two types of deposition. That is a sink or a fate of the chemicals, pollutants. That's the aerosol is a system of solid or liquid particles suspended by the mixture of air. Yeah. So these aerosols are again having a small ultra fine particles of 0.01 micrometer, having a homogeneous and heterogeneous nucleation process. It may also collide and form a bigger particles. So that's due to rapid coagulation and random impaction on its surface. Its lifetime is getting very shorter because once the particle size is less than 0.1 micron, then it is called aerosols. If it is having a bigger size, then it will become a dust. So the transformation during the natural gas to particulate condensation or during condensation of hot vapor to combustion process. So you could see how the aerosols are formed. The larger aerosol particles can accumulate into the atmosphere and removal mechanism are least effective. So if the lifetime is around 7 to 10 days only, that can be transported to a longer distance from their sources. Yeah. So how it got transported from its source to longer distance? Because it's having a particle size very less, so it can be easily transported. There are four mechanisms that governs the transport of this aerosol particles. One is advection, convention, dispersion, and diffusion. Everything seems like confusing, but very easy. Like you can see, advection is the simple transport due to wind movement. Once the wind is blowing from this side to this side, it will transport all the particles. That is called the advection. With the wind movement, the particles also moving. That is the advection. Convention is the one which may transported due to difference in the temperature or difference in any wind velocity. Then dispersion is the one having due to turbulence of the particles. So that is the eddy current mixing that will disperse the particle. Here it is 100 micrometer, here is 10 micrometer that I have discussed yesterday also. So it will disperse due to turbulence of the wind. And diffusion is the one, the movement is governed by concentration gradient. Because it is having 100 here and 0 here, the particle wants to move from here to here to maintain a equilibrium. That is called diffusion. You got it? So that's the difference between these four transport mechanisms. So advection is transported by the wind and it is responsible for the horizontal transportation. Convention is the movement of gas or liquid between that will be transported due to the heat difference, that is a temperature difference, and it will be responsible for the vertical movement. So wind may flow horizontal, so horizontal movement. Convection may create a vertical movement. And then dispersion, the pollutant may be dispersed due to turbulence in the what we say like due to concentration profile. Sorry, diffusion is the concentration gradient. Dispersion is by turbulence in the wind. Then how after transformation, what is the ultimate fate of the pollutant? Where it will deposit? How it will deposit? There are two methods. One is dry deposition, wet deposition. Again, it is removed by wet versus dry, dissolved in the waters associated with the cloud formation, and it will be deposited as the rain in along with the rain droplets. So when the OH radicals are present, that is called hydroxyl radicals. So those are all used in the advanced oxidation process in water treatment. We will purposefully produce this hydroxyl radical, and it will remove all the pollutants in the water, organic pollutants in the water. The same method, if the hydroxyl radicals are present in the air, then it will scavenge all the chemicals or pollutants present in the air. So in the troposphere. So that may form due to photolysis of ozone, and it will create OH radicals. These OH radicals are destroyed via the reaction with the CO and CH4. So it will be forming CO2 and CH3. So CO2 is less pollutant than CO. You could see that final product of complete oxidation will be CO2 and H2O. That are the two products it will form when it is reacting with the hydroxyl radical, or when it is reacting with the organic compounds. You got it? Yeah. So now we are going to see how the meteorological conditions are affecting the transformation or transport of this air pollutants. Now we had seen from the first day onwards, we are discussing about the air pollution, what is air pollution, its history, and what are the different air pollutant, how it is having impact on the human health, animals, plants, and soil, and different materials. Also on the atmosphere, like climate change impact, everything we had seen. We had then discussed about the different air pollutants and its sources based on different classification we have classified. Then we have seen about the transformation mechanisms and the fate of this pollutants. Now we are going to discuss how the meteorological conditions are affecting the transformation of this air pollutants. Yeah. So what is meteorology? Meteorology is the meteorology is the study of atmosphere and motion within the atmosphere. So we could see like in a short time scale, like minutes to weeks, the weather reports are given based on the meteorological data. So weather forecasting is every day we are seeing the weather forecasting in the news, and how the what manner the air pollutants are disposed and transported is governed by the weather patterns only. Okay, you could see like in Delhi also we could expect lots of dust pollution during the winter season, because that climatic condition or weather condition uh, prevents the dispersion of pollutants, air pollutant that is emitted. That's why we are avoiding the automobiles during winter season. Otherwise, the whatever the emission that will be trapped in the smaller area, and it could not be disposed. The weather condition will not allow it to dispose. So that's why if it is a calm and calm air, the pollutant cannot disperse. The concentration will build up. If it is a strong wind, then it is a turbulent wind will blow all the air pollutant and it will disperse quickly. You got it. So that's the meteorological impact on the dispersion of pollutants. So what are the meteorological data that could help? It will help in identifying the source of the pollutant. It will, because if it is coming in the one direction, then we could identify where the pollutant is coming from. Then it predicts the air pollution events and simulate and predict the air quality. Yes. So earlier history we are having a great history for the meteorological observance. Like Aristotle, they have used the word meteorology in the earlier days itself. In 17th century itself, we have a planetary scale single cell circulation system. That is like the earth is moving, so why the waves are forming in the ocean, why the wind is blowing, everything is based because of the movement of the earth and the gravity pull from the moon. So that creates a circular motion of the air due to the difference in the heat. So when the sun is here, it will create a radiation directly on the earth's equator, because the earth is in a sphere shape. The center equator part have more effect than the polar region. So there is a temperature difference. So this temperature difference makes the wind to move from one place to other, because whenever there is more heat, the air will become warmer. Whenever there is less heat, the air will be denser. So then denser air, the warmer air wants to move there, and the denser air wants to come here. So there could be a circular motion. The same will happen with the bottom hemisphere of the earth. So this is called Coriolis effect or Hadley circulation. Then they have discovered the three cell system based on the Coriolis effect. The global circulation have a three cell system. One is Hadley, Ferrel, and the polar cell system. So these three circulations are happening in the Earth surface in both the sides and both the hemispheres. That's a modern synoptic meteorological data was established in 19th century. So they have in 19th century itself, they have a radar development and they have started collecting the data of meteorology like upper air surveillance and the methods for analyzing the upper level atmospheric wave structures. And in 1950s itself, they have generated the weather forecasts. Um, you could see like Earth atmosphere was very thin, this much only the troposphere is compared to the other four layers. So 95% of the air mass is staying in this troposphere only, and then 20 kilometer of the Earth's surface that is having only this much is the Earth's atmosphere, and 20 kilometer deep with the air we can breathe and the pollutant we could emit, everything staying in the same thin layer of the Earth itself. That's called the troposphere. The lower boundary, which is the one that perfectly well defined but uneven, but the upper boundary is very thin but not as well defined. That's what the difference from lower boundary and the upper boundary of the atmosphere. Yeah. So you could see here again the thickness of 20 miles. If you open as a sheet and keep it in a plane, then you can see like most of the thing is concentrated at the center of the Earth mass. The thickness of 20 miles and the diameter of 1600 miles, you can see the larger width and the smaller depth means the motion of the atmosphere must be horizontal. That's why the air is moving horizontally. So the horizontal movement is driven mostly by the uneven heating of the Earth's surface. That's why the movement is horizontal. The horizontal movement is also governed by the rotation of the Earth. The Earth is rotating in a slight angle in a direction. So that's called the Coriolis force that governs the horizontal movement of the wind. So the what I said like due to solar radiation, so the annual solar radiation heat transfer was around 2.4 times at than the pole. So you can see the equator is having more solar radiation than the poles, like 2.4 times. So this difference in the temperature transports the heat from the tropic region to the polar region. So you can see here the equator warmer air, polar region colder air. So this air wants to move there because it is having less density. The denser air wants to come down. So this is depend on three processes. One is sensible heat flux, that is due to conduction and convection. Then the third one is the advection. So this three governs the movement of the air or the wind, that creates the atmospheric circulation. Yeah. So that is another term is called latent heat flux that moves energy globally when solid and liquid water is converted into vapor. Yes. So here you can see the surface heat flux that causes the horizontal movement of the wind flow. The large quantity of radiation energy are transferred in the Earth's tropical oceans. And this and all you can see when you are reading something regarding the climate change. You have a climate change course in the NPTEL also I have, I think. So you can read about the climate change and its basics. You will see about the Coriolis effect and the Earth movement and the wind flow. All are due to the difference in the heat and the solar radiation on the Earth's surface. So the cooler surface wants to move up, that is called advection, and the denser air wants to come down. So this circulation is happening due to the irregular shape of the Earth. When the Earth is not rotating, simply these two movements will happen. The atmosphere would circulate between the poles and the equator. Simply it will move. But when the Earth starts rotating, because it's rotating, there is a cross movement. Only this vertical movement is now transferred into a cross movement. That's why from the northern hemisphere towards the left in the southern hemisphere it's moving. That's called the Coriolis effect. It's responsible for many large scale weather patterns. Okay, this warmer air is moving diagonally to the poles towards the colder air. So here you can see the air movement around the low pressure in the northern hemisphere counterclockwise. In the northern hemisphere, it will be a counterclockwise movement. In the southern hemisphere, it will be a clockwise movement. And the wind will be upward. Here the wind will be downward. That is a high pressure system. During sunny and calmer weather, there is no dispersion of the pollutant. That is highly stable. We don't want stable condition for the dispersion of pollutant. We want unstable condition for highly unstable condition for the dispersion of the pollutant. But if it is stable, it will be calm. So in India also you could see like mountains like Himalayas, that's a barrier for the horizontal wind. So that affects the movement of the wind, and it is transporting, I mean changing the direction of the wind. So that's creating again a movement of wind in a irregular pattern. And heating and cooling effect of the earth surface. So earth surface can cool or can heat up easily when compared to the water surface. So if you can see like Chennai is having a beach nearby, so ocean is there, a land surface is there. Whenever the sun comes in the daytime, the earth surface starts cooling down, sorry, the heating faster than the ocean surface. So what will happen, the air above the land will be warmer, and the air above the ocean will be cooler comparatively. So the cooler air wants to move here, and the warmer air wants to move to the ocean side. So this movement is circular movement will happen, horizontal circular movement will happen. So that is due to the ground heating and cooling effect only. Yeah, you can see here the land will get hot and faster, so it will start moving up. So that's creating a circular motion. Yes. See here, the hot land and the land heats up quickly. The cool air from the seaside will come here, and the warmer air will rise up, and then it will start again cool down, and it will go to the ocean. So this type of circular motion will happen. That's why we are feeling the breeze in the ocean sides. So same will happen opposite in the night time. So the night time, the earth starts cooling faster. So the dense air will move from here to the ocean. So it will be the opposite direction. So this is governed by the perfect gas law, like PV equal to RT, PV equal to nRT equation. This is the basic formula. So you can see the density is inversely proportional to the temperature. Everything governs the movement of the wind. So here also you can see in the normal condition, Earth will be like warmer here, colder here at the upper. But if it wants to circulate, it will be the temperature inversion condition. As a result, convection caused by the air heating below is limited to the levels below the inversion. Yeah. That's why it's not fully transferred. Only the limited level of cold air is at the bottom layer. Yeah. Here you can see again the temperature is directly proportional to the pressure. As the pressure increases, density increases, temperature also increases. It has PV equal to nRT formula again. So these five are the meteorological parameters that governs the wind movement. One is wind speed and direction, temperature, humidity, rainfall, and solar radiation. The first one is the solar radiation. Is like this governs the movement of the wind. As the Earth moves, the equator is getting hotter faster. So again, the sunlight is responsible for the ozone and the smog formation. The wind speed and wind direction, how we can measure? So why we are measuring? Because the wind data can be determined by the general direction and the area of emission that is required to plan and reduce the impact on the air quality. Yeah. So COVID also they have measured the wind speed, and they have predicted how much population is getting affected. In the same wind direction, all the people are getting affected in a single area because all the wind are concentrating in that area. So the wind affects transported this type of air pollutant. COVID is again an air pollutant only, the virus. So that would transported easily when wind blow is there in a single direction. Yeah, temperature we can measure. It affects the movement of the air. Because of the temperature gradient only, the circulation is happening. Yeah, that's called the thermal inversion. And yeah, here you can see in the ground level ozone is, as we know, is more efficiently in summer, sunny and hot weather because the sunlight is responsible for the production of ozone. So it requires sunlight. So ozone often reaches dangerous level in the cities in the nearby rural areas during the summer season. Then the relative humidity, that is another meteorological parameter. How much water vapor is present in the in the saturate level in the given atmosphere. That is in the given temperature in the atmosphere. That is called relative humidity. So that will affect the formation of acid rain. Yeah. So that is an important role in thermal and photochemical reaction. It requires water. Again, a smog formation requires water. Small and water molecules are smaller and higher polar. So it's suspended in the air and they can reduce the visibility. That's a mist. Mist is due to the smaller particulates of water vapor that will affect the visibility. Yeah. Relative humidity is generally higher during summer uh, because there will be less water vapor in the atmosphere. Sorry, higher water vapor in the atmosphere due to the evaporation of ocean water. Then rainfall. Rainfall is again there is a scavenging effect that may happen because all the pollutant in the atmosphere will be taken by the rain droplets and it will be deposited in the land. So during rainy season, after rain, you can see a clear visible mountains because all the particulate matter in the air was scavenged, or what we can say, swept by the raindrops, and it will be deposited in the land areas. So we can also measure this meteorological parameter with the different instruments. Wind speed and direction was measured by sonic anemometer, and temperature you can say thermometer, and relative humidity with the humidity meter, rainfall with the tipping bucket rain gauge, and solar radiation with the pyranometer. These are all simple equipment. You can say like how it's working. You just know its basics like sonic anemometer. You can see how much the speed of wind it is affecting based on the sound of the light it could travel. Sorry, the speed of the light it could travel from one point to another. So they are sending one sound wave from here to here. So if there is a lot of wind, then it will take a lot of time to reach there. If it is a calm wind, then it will be fastly it will reach the other electrode. So based on that, they are measuring the wind speed and wind direction. Then the thermometer with the platinum electrode, they can easily measure the temperature difference by potential differences. Then relative humidity was measured by either absorb or loss of water vapor in the sensors. Tipping bucket is the one, it's the animation. You can see if there is a more rainfall, then it will oscillate faster. If it is a less rainfall, it will slowly oscillate. So based on this oscillation, you can calculate how much precipitation or the rainfall happened. And then solar radiation can be measured by pyranometer. It's a silicon cell based sensors. You got it? So in the finally, we are going to think about the stability. So now we know the meteorological parameters like wind, rainfall, humidity, solar radiation. These are all affecting the transformation and dispersion of the pollutant. What will happen if these things are more or less that we are going to see in the atmospheric stability. So that will be again a concept of lapse rate will come. So we are moving into this. Yeah. So atmospheric stability. What is called stability? Stable means very calm. So the pollutant will not disperse. But it is good for environment. But we want a unstable environment for unstable condition for the dispersion of the pollutant. So it should not. It should be unstable. There should be a turbulent wind. Okay, required for the dispersion of the pollutant. You can see what is stable. This ball here is stable. If you move here, it will come back. If you move here, it will again come back. But if you move slightly here this side, it will go out. Here, this will go out. So this is an unstable condition. But neutral, if you see, whatever the force you give, that will stay into on own position. Then it is called a neutral one. So we are emitting a parcel of air from the chimney or any industry. You can say one parcel of air or one bubble of air pollutant is coming out. How it is going to disperse? How it is going to expand? That's what we are going to see in the stability conditions. So if it is unstable, it will disperse fastly. If it is stable, it will stay on its own place. Okay, slowly it will disperse. If it is a neutral, it will stick to there. That's the condition. Yeah, here you can see once there is a two phenomena. One is rising phenomena, another is sinking phenomena, another one is neutral phenomena. Neutral is it will stay on its own place. So if it is a stable condition, it will sink. If it is unstable condition, it will rise and expand and disperse. If it is a neutral condition, it will stay on its own place. Yeah. So unstable will be again based on atmospheric stability. You can see this concept. You please try to understand. If you are emitting a parcel of air at a temperature of 15 degrees Celsius, that is a particle or a bubble having a smoke, and then the outside temperature is 10 degrees Celsius. That is the ambient air temperature or environmental temperature. So or adiabatic we will say. Okay, so this temperature of the air parcel, the pollutant parcel and the air difference will give you the stability condition. So you can see the 15 is warmer air and 10 degrees colder air comparatively. So the 15 warmer air will try to rise because it is very light density. Because warmer air are lighter density, colder air are very denser. So it will want the outside air will wants to move down. The parcel air parcel will wants to move up. So it will move up and it will disperse. So this is an unstable condition. The same if you see the particle what we are emitting is 8 degree only. So it is comparatively colder. So the outside air will push up and the particle will be pushed down. So this will go down, sinking will happen. That is called a stable environment. If it is in a neutral environment, both are in the same temperature. That will not help in dispersion of the particle. It will not rise and it will not sink. So the temperature of the parcel and the sorry, ma'am. Okay. So the temperature of the pollutant parcel and the temperature of the atmosphere, difference in this will give you the stability condition. Hope you understand this. Yeah. So based on this, we have three lapse rate. Lapse rate is the one which is the change in temperature with the altitude. So how it will be here? We are feeling hotter. If you are going to mountain, you are feeling colder. So if you go in with altitude, the temperature will reduce. So I am here at 10 meter. The temperature is 20 degrees Celsius. I am going to 1000 meters in a hill. I am feeling 0 degree Celsius. So it will reduce. So we are here. We are having a. 1 second. I will take a pen. Okay. Yeah. So here we are having the theta. You got it. So the theta will be opposite to adjacent. So tan theta will be opposite is the temperature. Change in temperature. Adjacent will be altitude. So change in temperature by change in altitude will give you the lapse rate. The theta is the lapse rate. You got it. So that is very. You have raised the hand. You have any doubt, ma'am? Yeah. Okay. I will continue. So one is dry adiabatic lapse rate. Another one is saturated adiabatic lapse rate. The ELR is the environmental lapse rate. So this is always same. Whatever the whatever the environmental lapse rate, sorry, environmental lapse rate will vary, but the dry adiabatic lapse rate will be the same. Whatever the parcel we are emitting will always reduce 6 degree Celsius per kilometer. If it is a saturated, you could see here, dry adiabatic lapse rate will be 9.8, that is the dry adiabatic lapse rate, unsaturated. If it is a saturated, you could see it will be 6 degree reduction per kilometer if it goes up. You got it. So this is the two important thing you could see. The DALR and SALR, adiabatic lapse rate, dry adiabatic and saturated adiabatic lapse rate is common. 9.8 degree reduction with every 1000 meter or 1 kilometer rise. But the environmental lapse rate may vary based on different cities and different climatic condition and different time, morning, evening, like that it will vary. The environmental lapse rate will vary. So the measured EALR will be compared with both DALR and SALR and determine the atmospheric stability condition. That's what we have discussed earlier also. We are measuring the environmental lapse rate, and we know the particle lapse rate, that is maybe minus 9.8 degrees per kilometer. We have to compare both and we can easily determine the stability condition. You got it. In the troposphere, when the temperature of the ambient air normally decreases, that's called with the distance, the temperature will decrease. So del T by del Z will be the lapse rate. Got it? That is the environmental lapse rate or adiabatic lapse rate. How to find the environmental lapse rate? We are ejecting a balloon. So the helium balloon, how much it is going, and measuring the temperature at different heights. That will give you the environmental lapse rate. How you know the adiabatic lapse rate? That is by the equation they have framed. Two things. One is dry and saturated adiabatic lapse rate. So there is one you have to very much you have to know very keenly. It is adiabatic. Adiabatic is the process. There is no exchange of heat. So how the heat is reducing then 30 degree to 20 degree when it is moving up. How the heat is getting reduced? It is not transferring any heat with the outside air. It's only trying to expand, and during this work done, there is a loss of energy. When you do some work, you will lose some energy, right? So the balloon is getting expanded and it is getting reduced. So this balloon is becoming bigger and this work done is losing some energy. So 30 degree reaches to 20 degree and then 20 reduces to 10 degree. So you please be mind there is no transfer of heat with the atmospheric air. So that you have to note down. If it is a transfer, then it is not adiabatic. Okay, adiabatic process is the one that will not transfer any heat. Thermoflask, you know, right? Thermoflask is the adiabatic system. It will not transfer heat with the outside system. Yeah. So DALR will be 9.8 degrees Celsius per kilometer. That was framed calculated with the ideal gas law and the different equations. And the same was calculated for with adiabatic last night, and you could see that 6 degrees Celsius per kilometer is the temperature reduction. Yeah. So now we know what is DALR, what is ELR. Based on the DALR and ELR, we could see the stability condition. So you see the environmental lapse rate is higher. Measured environmental lapse rate is higher than the DALR. And what is this measuring like? It's slowly it's reducing, then it is a the air parcel will get cool faster because air parcel is here only, so it will cool faster, so it will than the surrounding environment. It will rise, it will not rise, it will only sink. If the same, you can see absolute instability, ELR will be down. So that degree you can see theta here, theta will be very big, theta 1, theta 2. So if the ELR is having a larger value, then it will start. It's a instability condition. So the air parcel will rise and it will disperse. The instability is the dispersion condition. Yeah. So if it is a similar one, in between the DALR and SLR, it will not. Saturated parcel will be unstable and the dry parcel will be stable. You can see the saturated parcel is above the ELR, so it is a stable condition. The DALR is less than the ELR, so it is a unstable condition. If it matches, then it is a neutral condition. ELR is SELR is a neutral condition here. Here DALR is a neutral condition. Okay. Then specific, this is another worst condition, that is cooling with increase in the temperature with altitude. That will happen during daytime. This type of inversion may happen. So this inversion is this type of process called the temperature inversion. So that is purely stable condition, absolute stable condition, that will not even disperse the air pollutant, that will make the air pollutant to stay in a particular region. Yeah. So you can see that adiabatic lapse rate, if it is here, that is super adiabatic, then it is subadiabatic. Once opposite, it is called inversion. Yeah. And the ELR is less than DALR, then it is called unstable condition or super adiabatic lapse rate. If it is ELR is greater than DALR, then it is subadiabatic or the stable condition. Yeah, no need to mug up this. You can easily know if the ELR is slowly increasing, it is fastly increasing, then how much it will be. 10 degree, 8 degree, you can compare and you can say it is sinking or it is rising or it is neutral. Yeah, if it is a neutral, DALR equal to ELR. Inversion, DALR will be in one direction, ELR will be in one direction. So when the inversion will happen, this type of negative lapse rate, when it will happen, there are four conditions that may give this inversion. One is ground radiation inversion, turbulent inversion, subsidence inversion, frontal and valley inversion. So ground radiation is the one. As I mentioned, the land will get cooler or hotter faster than the surrounding environment. During midnight or late evenings or after sunset, you can see the bottom air is started cooling, but still the upper air is hotter. So it wants to come down. So this type of inversion may happen. Okay, turbulence inversion due to mixing of cooling air. You could see like here there is a normal thing and the inversion is here. So this remains warm. Subsidence inversion, when the descending air is compressed and warms adiabatically. The upper air wants to compress the bottom air. You could see an inversion in the middle layer. Yeah, radiation inversion. Due to the sunlight, it may cause during the daytime, it will be a inversion. It starts hot heating faster than the upper air. Then frontal inversion. Some area there may be a cooler air, some area there may be a warmer air. So this want to shift. There is a push from the colder air to the warmer air, and the warmer air rises up. This is the reason for what we say, like summer rainfalls and all. This is the reason. So it will push and the warmer air will move up faster and the clouds will be formed. So this is called a frontal inversion. Then the valley inversion. If you are between two mountain region, that is a valley region, then there is a emission from the industry. Then we have an inversion condition here. The pollution will stay in this place only. So it is not recommended to create an industry in the valley regions because there is an inversion condition. Here also it will be colder faster, but warmer faster, but the cold air will be at the top. So that's the inversion condition. Yeah. So here today we have discussed a lot about the meteorological conditions and its impact on the dispersion of the air pollutants. So you have any doubt, you please unmute and you can ask, or you can post it in the chat box, or I will move on to the problem solving session. Anyone have a question? Please raise your hand, or you can unmute and you can ask. No issue. I'll wait for a minute. Okay. I will move on to the problem solving session. Please post your answers in the chat box. Please post the answers. Yeah. What term is used to describe the measure of how well an observer can see a scene? So transparency, luminosity, visibility, albedo. What term is used to describe the measure of how well an observer can see a scene? You can post the answer in the chat box. A, B, C, D. You can take. Yeah. So here, if the observer is cannot able to see the scene, then it is a visibility problem. So that is the measure used to measure the flow of how well an observer can see a scene. That is visibility. So B, C is correct. Yes, C is correct. Visibility is a measure of how well an observer can see a scene. So that's the if a contrast curve decrease, the visibility will get decreased. Yeah. Second question. How can air pollutants such as SO2 and NOx affect environmental issue? This is what we are discussing for the last 2 weeks. Increase in the rainfall amount, formation of acidic rainfall, reduction in rainfall intensity, no impact on the rainfall. Can answer A, B, C, D, anyone? Yeah. So kindly answer the question like how the air pollutant SOx and NOx. This is the major thing that could impact the acidity of the rainfall. So formation of acidic rain is the major issue with the SOx and NOx. So formation of acidic rain is correct. Yes, correct. So here we have is mentioned like air pollutants such as SOx and NOx can create acidic rain. Even CO2 also, because CO2 will give you the carbonic acid. It's not A, sorry. It will not increase the rainfall amount. It will form the acidic rainfall. Yeah. We'll move on to the third question. What harmful properties of aerosols from ozones possess, especially at coastal locations? Cooling effect, corrosive property, moisturizing effect, neutral properties. What are the harmful effect of aerosols from the ozones? That is called ocean aerosols or marine aerosols. So it will have, what are the aerosols in the marines like salt? Salt have effect of corrosion property. So it's not cooling, it's not moisturizing, it's not neutral property. It's a corrosive property. So answer B is correct. Yeah, B is correct. Exactly. So ocean aerosols have the corrosive property that's harmful. Then fourth question. How are film drops formed in the context of aerosol production from bursting bubbles? We have seen like from the ocean, the aerosols are getting emitted into the atmosphere. So there are two things. One is film drops, one is jet drops. So film drops are formed by shattering the thicker layer of the atmosphere, shattering the thin upper layer of the atmosphere by direct emission from the ocean surface by condensation of water vapors. Yeah, option B is correct. By shattering the upper surface of that upper surface of the bubble. So the bubble will start coming to the ocean surface, and it will be at the upper surface of the bubble. It will burst into smaller droplets, and the aerosol is emitted into the atmosphere. In jet, it will be the larger aerosol uh, directly emitting into the atmosphere. What compound can be produced during incomplete combustion? Incomplete combustion. If it is a complete combustion, carbon dioxide and H2O will be formed. If it is a incomplete combustion of organic compound being oxidized, then what will happen? Ozone and nitrogen oxide, methane and ethane, polyaromatic hydrocarbon, dioxin, furans and carbon monoxide, sulfur dioxide and particulate matter. Yeah. So if it is more oxygen, then C carbon will react with oxygen, form CO2. If it is less oxygen, then CO will be formed. So carbon monoxide is the major answer, must thing in complete combustion. Then if it is an organic compound, then surely polyaromatic hydrocarbons, dioxin, furans, it's a plastic emission will happen. So option C is correct. Yes. Yes. So these are all the products of toxic products of incomplete combustion, such as polyaromatic hydrocarbons, PAH, dioxins, furans, and carbon monoxides. Which one of the following is are produced during the complete combustion of organic compounds? CO2, CO2, H2O, CO, H2O, H2O. This I have already answered, I guess. If it is a complete combustion, what will happen? Complete combustion, excess of oxygen will be there. So, excess or a required amount of oxygen will be there. What will have? What will be produced? Yeah, B is correct. CO2 and H2O. That is correct. So if it is a complete combustion, CO2 and H2O will be produced. Whatever the organic may be, you have given the enough oxygen and combust, then product will be only CO2 and H2O. What would be the atmospheric circulation pattern if the Earth did not rotate and remain stationary? We have mentioned, right? If the Earth is not rotating, then only the center heat will wants to go to the pole, and the pole wants to go to the comes to the equator. So if there is no Earth rotation, then simple back and forth pattern between the poles and the equator will happen. So yeah, B is correct. Exact. Yeah, B is correct. As the Earth is rotating, what's happening? The air is start moving from the equator to the in the northern hemisphere. I am talking about. So equator to the northern poles in the anti-clockwise direction, counterclockwise direction. In the southern hemisphere, it will be a clockwise direction. Okay, that's a downward. That is upward. So if the Earth is not moving, then simple back and forth pattern between the poles and the equator. That's what we had seen. That's why only two things are happening, but now they have a Coriolis effect and they have three cells that we are going to see in the further questions. Which one of the following weather patterns is responsible for the sunny and calm weather with poor dispersion of air? Anticyclones, cyclones, El Nino, and La Nina. These are all the episodes of weather which will create a sunny and calmer weathers. Anticyclone or cyclone? Yeah, anticyclone is correct, exact. Because anticyclone is the one which will happen in the high pressure system. So the center will be having high pressure, sorry, low pressure, and it will create a calm and sunny weather. What is the dry adiabatic lapse rate associated with? Moist air parcel, unsaturated air parcel with high humidity, completely saturated air parcel. We have two lapse rate, sorry, three lapse rate. One is environmental lapse rate that will vary with the environmental condition. Other two are adiabatic lapse rate, dry and saturated adiabatic lapse rate, DALR, SALR. So DALR is related with the unsaturated air parcels, not C. Unsaturated air parcel. SALR is related with the saturated air parcel. You can see here. So its relative humidity is less than 100. It is unsaturated air parcel. If it is a saturated air parcel, then it's called SALR. Yeah. How does the heat released by condensation affect that the wet adiabatic lapse rate? How does the heat released by condensation affect the wet adiabatic lapse rate? I think this point I have missed in the lecture. It mitigates the adiabatic cooling and resulting in the warmer air. Because in the wet adiabatic lapse rate, you could see it started moving up and wet adiabatic lapse is the saturated air parcel, right? So it will be having 10 degrees Celsius per 1000 minutes. So it will start and after reaching a point, it will be 0 minus 6 degrees Celsius per minute per kilometer. So you can see the heat released by the condensation mitigates the adiabatic cooling effect. So resulting in the parcel of air being warmer than what it could be. So that's why it's only 6-degree reduction in the temperature is happening. That's called a wet adiabatic lapse rate. That's the heat released by the condensation. What is the ideal water holding capacity of the soil for the plant growth? There are four important parameters we had seen for the soil. One is pH, one is NPK, that is a nutrient, one is water holding capacity, the other one is salinity. Yes, the four important parameters for the soil required for the plant growth. So water holding capacity should be 40 to 50% for the plant growth. 40 to 50%. Yeah. This water holding capacity is the one, the amount of water the soil can hold after draining the gravity. Yeah. The soil which contain calcium carbonate is more resistant to acid rain, vulnerable to acid rain, no effect on acid rain. This I have told you. When the soil is having CaCO3, when it is reacting with the acid in the rain, then it will form calcium sulfate, and there is no resistance, more resistance to the acid rain. So answer A is correct. When soil is having calcium carbonate, it will form calcium sulfate. So it will not affect the soil. When the soil is not having calcium carbonate, then the H2SO4 will affect the soil. So if it so here you can see. Calcium carbonate chemically neutralizes the acid, so more resistance to the acid rain. Soil that contains lower level of calcium carbonate are vulnerable to acid rain. Please understand this concept. Yeah, yeah, got it. Okay. Which of the following is not a criteria air pollutant? So the NOx standards, Indian NOx standards, National Ambient Air Quality Standards, given a guidelines for the six criteria air pollutant, which is not the criteria air pollutant. Ground level ozone, particulate matter, lead, SO2, NO2, carbon monoxide. So ammonia is not the criteria air pollutant. Yes. Ammonia is not the criteria air pollutant. No, no, no. Ground level ozone is a criteria air pollutant. You can see here. This is a sixth one. Things given by EPA and also given with the NOx standards. Ground level ozone, particulate matter, carbon monoxide, lead, sulfur dioxide, nitrogen dioxide. In the modified rule, we have a 12 criteria air pollutant, including benzene and all. Yeah. Which is not the global circulation cell based on the Coriolis effect. While the Earth got started moving, we have a three cell formation due to Coriolis effect. What are the three cells? Polar cell, Ferrel cell, and Hadley cell, and which is not the one, Westerly cell. So option D is correct. Westerly cell. Yeah. Polar, Ferrel, and Hadley cells are formed when the Earth start rotating, and the Westerly cells is not there. Yes, that's correct. So here you can match the meteorological parameter with their measuring instrument. Wind speed, how can we measure? Temperature, relative humidity, rainfall, solar radiation. You can easily match. So relative humidity can be measured with relative humidity meter. Temperature can be measured with platinum resistant thermometer. Rainfall with a tipping bucket rain gauge. The tipping bucket we had seen, right? The animation. Solar radiation, pyranometer, wind speed, anemometer. Wind always can be measured with the anemometer only. So the answer is 1B, 2D, 3E, 4A, 5C. Option C is correct. Okay. The final question. Which of the following condition is worst for pollution dispersal? This is what we had seen at the end. Super adiabatic lapse rate, subadiabatic lapse rate, neutral. Super adiabatic lapse rate is unstable. Subadiabatic lapse rate is stable. Neutral is neutral condition. Negative or inverse lapse rate is the inverse condition, which is worst for pollution dispersion. Not C, not C. Neutral is also worst, but which bad, but which is worst? The inverse lapse rate. Yeah, inverse lapse rate is the one which is extremely stable. So this traps the pollutant, it will not disperse the pollutant. So inverse lapse rate is the worst condition. Neutral is also worst, but inverse is very worst. So thank you so much for attending. Please don't forget to attend the assignments in the week 2. Today is the deadline. Please attend the assignments for the week 2 session. For week 1 also today is the deadline. So next week onwards, Tuesday 6 to 8, is the class timing. Please attend 6 to 8 every Tuesday. You will get the mail regarding this. If you don't have any doubt, you can leave the meet. If you have any doubt, please unmute and you can ask or put it in the chat box. Thank you so much for joining. You can leave now. Yeah, thank you so much. Yeah, if you don't have any doubt, you can leave the meet or you can unmute and you can ask or you can put it in the chat box also. Yeah, I hope nobody have any questions. I will end the meet. Thank you so much for joining. Yeah, thank you. I'll end the meet.